Okay, so in today's video, I'm going to be covering the question 5 on exam 2, just to briefly explain what exactly I did wrong on there. So I'm going to be fixing those issues. So I'm going to be going over this problem. So in question 5, suppose a colony is divided into two regions, the plains and the mountains. In each region, there is an equal amount of resources that collectively can serve the needs of its 22,000 inhabitants. Inhabitants move from the plains to the mountains with probability 23% each year. People move from the mountains to the plains with probability 16% each year. Each inhabitant that does not move is assumed to stay put. We assume the net population is always 22,000 inhabitants. Currently, the mountains have been the least inhabited with only 7,000 people. So, the percentage values that we're getting for each year, as we see here, they're basically letting us know the state diagram that we see down here. Draw a clearly labeled state diagram. So it's letting us know what the state diagram is going to look like. And the 22,000 inhabitants, that's supposed to be assumed that that is the total population between these two regions, the mountains and the plains. So this fixed number will always be the equal amount. It will never go up or never go down. So if we know that 22,000 inhabitants is the total population between plains and mountains, and it lets us know that mountains is the least inhabited with only 7,000 people, then we can assume that 22,000 minus 7,000 is supposed to be the plains amount, which I believe is 15,000, if we needed to know that value. But for question 1, so we're going to see draw a clearly labeled state diagram. So if we head on over here, we see I've already done the math, but I wanted to go over step by step. So in question 5A, we see that this is the boxes are supposed to represent the regions. So this is P is for plains, M is for mountains, and those percentages we saw in the paragraph are supposed to represent the probability of moving around. So plains will be 23% of the people living in plains will move over to mountains, and 16% of those in mountains will head on over to plains. Also, we assume that those that are not moving will just stay put. So 77% of those will stay in the plains, and 84% of those will remain in the mountains. And for part B, it asked us to create a system of equations from the state diagram. Construct a system of linear equations for the number of inhabitants in the plains and mountains next year using these variables as a function of the number each year of the regions. This year, P, N, C, N. You can use any variable you really wish to, just something to label the areas. So we went for P and M. So as you see, we basically just move these percentages down over here. So whatever is going into the box of plains, so 16 and 77. So 77 originated from plains, and 16% of that originated from mountains. So that's why these variables are very important to distinguish where they actually came from. And this is just the total, like where the box is going into. So right here we have mountains right over here, and then we have 23% of those are going from plains into mountains, and 84% of those are coming from the mountains and staying in the mountains. And basically the orientation that we make this is very important as well. If we're going to say plains is right here, we have to put plains down here as well. So this goes for if mountains are going to be right here, the mountains have to fall right down below it if the matrix is to be set correctly. So right here, earlier when I spoke about the inhabitants, the amount of inhabitants in each area, so we have P as our first, and then we also have M as in the bottom right here, P and M. So this is important. So this is basically letting us know that there's 15,000 inhabitants in the plains region and 7,000 inhabitants in the mountains region. And this is all at X naught. So this is basically saying at the initial. This is an initial value for us. So heading back over to look at the other questions, construct a matrix equation out of your system of equations. So it's just a trailing. So we had from A to B, now B to C. So in C, all we basically did is constructed a matrix equation. So we're just stating like this matrix right here is equal to, so all we did is remove the distributive property, almost as if saying that the P were in these two values and then the M variable were in these two values. So now we just have a distributive property sort of. And now we can go ahead and construct that matrix that we needed. So I actually already did the matrix as well. So if we head on over here, we have A, 0.77, 0.16, 0.23, 0.84. It's important that we keep the distinctions there. And B is equal to this value right here, 15,000 and 7,000, which is our initial value. So just keep in mind this is supposed to be X naught. So if we head on back over here, we've already completed question C by simply constructing this, the matrix. So heading on over to D, how many people will live in each region after 5 years, 10 years? A very long time. So what we're basically going to do is we're just going to be estimating. So we're going to say 5 years, then 10 years, then 15 years, then 20 years. But all we really need to do is do the initial, the ones they asked for us, so 5, 10. I didn't include the 10 in here, but the 5 and 10 are very not so different. But if we know what the actual steady state is which is when plains and mountains reach a steady state equilibrium. So in this case, as t approaches infinity, you get 9,026 people in the plains and 1,297 in mountains. It's basically saying as a keeps rising, as a to the n just keeps rising and rising and rising and rising, times the x variable, this is what we're going to get. So if we go back over here to our Desmos, so I did the a to the 5th, so that's values that we got back over there, a 20th, and then just to confirm that this would be our actual steady state values, a to the 50th, yep, so 9,000, yep, so that's about the same. So then heading down to E, the final question, I'm gonna head back to the questions. Using the concept of a mathematical steady state, calculate the actual steady state to prove your answer in part D, just like we did in the lesson. Okay, so if we head on over to E, we're basically going to use this formula to prove as to why, to prove our actual steady state. So we're going to get rid of, we have to go back to the inverse, sort of like the inverse formula. So if we're going to do that, we're going to subtract the I, and then the x's can just kind of get pulled out of the parentheses. So now we have a minus I x, and the vector of x is equal to the 0 vector. So then if we move this on over here, these are the actual values. So this is supposed to represent a, this is supposed to be a representative of I. And if we look right here, I formulated that. So this is after the subtraction of what happens here. And then x, or our 0 vector, is simply right here. It's just supposed to represent our equal signs. So once we do this, and we REF it, or reduce row echelon form, this is the values that we're going to get. So if I head on over here, I already did that as well. So this is the actual Desmos matrix that I've calculated right here. So I'm going to head back right over here. So that's what we got. So this is basically just saying that for 1 or plane, so our value down here is supposed to be m, but 0 is equal to 0. So m is supposed to be a free variable. So we said m is free. And right here, this is the original. So p minus 0.7 of m is equal to 0. So if we move on over, if we move our 0.7 over to the other side, we're basically saying that p is equal, this is supposed to be a 0.7, sorry, apologize for the 6. So that's supposed to be 0.70, and we're basically saying p is equal to, or c, and then that's its equal value counterpart down there. So if we look at this bottom portion right here, if we were to do the REEF of B, so what we're going to do right here is all we're going to do is add extra values here. So I'm just going to add an extra row. So we're going to say 1, 1, and this is the total inhabitants of 22,000. So this is supposed to give us the actual value of how many people remain in each area. So this is going to be our plains, and this is going to be our mountain region. And if we look back at what we had said originally, it's pretty spot on. The similarities between those two are identical. So we're basically just proving the fact that this, using this formula, is actually this steady state right here. So that's all we did right there.